Hello everybody, welcome back. In this episode we will be arriving at the big result that I said in the last episode. Again, I film these in chunks, and once it gets about 15 minutes I just go to another episode, so they're filmed at the same time. It's not like a teaser or anything. Not that anyone watches my stuff. But I'm going to start with a quick story this episode, and then we're going to go just pretty much straight up, pretty much straight up mathematics and logic, extending, working towards our axiom. So I call this the counting conundrum. So I play a lot of board games with my parents. One of the games we play is Parcheesi. If you played it or if you haven't, just Google it. It doesn't really matter how the game's played. Point being, you roll some dice and you move little pieces around a board and you try to get them into a certain spot. Point being is if you have a space occupied, another person can't come and land on that space. And so my mom, when she's counting, she would, well, not all the time, but when she would count forward and she would have a starting spot, and then she'd go 1, 2, 3, 4, which is how anyone would count. And then sometimes she would get to a spot where the piece was occupied, and she couldn't put the piece down. And so she would have to back her piece up. And for whatever reason, when she goes to count backwards, she counts the space she's on. So when she's counting forwards, she has a starting position, and then 1 is that transition to the first space she moves to. But then when she counts backwards, for whatever reason, she goes 1, and then goes to the next space 2. And so, and me and my dad joke with her, mess with her lightheartedly. But I actually had that deep intuition when I was a kid, why do or do you not count the base as a starting position, right? Like if you have 1, right now we've talked about one thing, one object, but one movement, one step. And so it's like, why not? Why don't you count the base? Why is it wrong to say 1 and then just tap it? First of all, why don't you do that? And then why was it instinctual or just haphazardly when she went in the reverse direction to do that? Because I've had that same intuition. Again, literally, I remember it's one of my first intuitions. Again, before going to preschool, is why don't you count the base? Or do you not count the base, and why? And so again, we had lighthearted laughs and jokes, but why or why not? And again, we don't count the base, right? You have a starting position and you count 1 as that first transition, and so you kind of count the transitions of states. But a fun, true story and very, very intuitively deep, because I 100% had that as a child, and it's still kind of just right? When's your first birthday? Well, it depends if you're in China or not. Or in multiple other cultures as well. But, when does a conversation start, right? That when does, acceleration happen? Those phase changes, the transitions, those are when all of the interesting things happen. So, again, in a lot of languages, right, you're just you say, how are you? Starting a conversation is not that direct as to what you say. And so it's all very interesting, starting and stopping, counting. Something as simple as just counting 1. What exactly are you counting? Where you start, where you're going, the transition. And so I call that the counting conundrum. But moving on to trying to, again, just a little bit of logic from the last episode. Words what do we do? Okay, so I talked about prefix, complete word, ending suffix ing is our ending solution. And for whatever reason, for speciality, it was very clear that the letter had to be E for especially, and then especially, I forget even what the axiomatizing sentence was. I could literally just look it up in my email, but it's really not consequential because sensorality has to be unique and new, so I have to do the whole thing again anyway. But I don't look up anything I've done before or repeat any stuff. Well, I probably repeat it, but I don't personally go look at it. I don't even watch these lectures really much anymore. I have to edit them, so that's when I see them. So again, we have to have some sort of prefix with E, like incensor or incensorate, or just shooting for. But I'm assuming it's going to be with an E or with an en, but it'll just come naturally from the derivation. It'll be a complete integrated word, which will be sensor or some form of sensorality, and then another word. Or it'll end in ing, and then you can connect that, and it'll connect to the next axiom. But it'll start, probably prefix will be E or en, complete word with some form of sensorality in the middle, probably serality, and then ing at the end. And that fundamental ing, right? Sing, wing, thing, right? It's very clear that it's the fundamental base syllable. And so, can we extend factoring to syllability? Our same rules that we apply to factoring something as simple as x squared plus x equals 0, right? Your basic parabola. What are you really doing when you factor out? You take out an x, you set it equal to 0, you divide by x, you minus the 1, then you have x squared equals 1. And so you get your roots of plus or minus 1. And so again, negative numbers, again, obviously clearly have no physical meaning. You can't have negative something. Spend no time on that. But like, again, what are you doing? Again, the equality sign says this equals that. But again, you're finding the intersection points. But you're removing variability when you factor that out, or when you set it equal to, or more importantly, when you set it equal to 0. Because that's when you can move the 1 over to the opposite side of the equation sign. And so, again, how would we apply that type of logic, generalize it and apply it to syllables? Again, what would we factor out? The consonants? Would that be the same as a scalar, as a factor, as some sort of iteration? Or again, trying to think the logic out loud, would I subtract the consonants, subtract the vowels, subtract the syllables as wholes? But again, I just think of like irate and vibrate, and you're taking away the V and the B, so you're taking away, it seems to be consonants. But just look at a bunch of examples, what can we say about that? And probably can do something. In the same way, if you take 6 plus 8 equals 14, you can factor out a 2, and you get 3 plus 4 in parentheses times 2. And so you get those distributive properties for addition and associative properties for addition and subtraction, but not, or for addition and multiplication, but not for subtraction and division. You can kind of bound subtraction because negative numbers don't really do anything, and you can bound. We have bounded all of the physical or all of the mathematical operators physically, but you could probably say something more poignantly about the difference between subtraction and division. Someone at Harvard can do that. I don't fucking care. But equations relate elements, right? So elements, the word you use for that complete, distinct, unique space, and what you do, you increase or decrease that somehow by some magnitude or by some function or set or tensor or whatever, and it changes that base. So again, base is much more important. These fundamental words are much more important in general and applicable than tensor or the Hilbert-Einstein quasar space. But now to get to our final result, our poignant result, is that unique, condensed syllability, unique string of letters that hasn't been used before, and pairing it to our axiom sensorality, which guess what we can do, right? So sensorality is sensory, anything with senses. And so the final reduced thing is going to prove why it's spelled with a S and not a C when you see censorship, but who really cares? But sensory, senses, sensing, sensorality, senses, singing. Or no, sensorality, senses, sensing. And so we've iterated that sen prefix 3 times with unique logic, sensorality, senses, sensing. So it's very clear, that's uniquely different. But then you have sensing and singing. And so you have ing squared. So you just have S and then ing, literally. You can't prove that wrong because it's literally just right there on your screen. So what is singing? Sensorality sings. Sensorality is singing. And then they say sensorality is sinning, right? Sinning, like you do something bad, you're sinning. And so how do you spell that? S-I-N-N-I-N-G. So they say, back in high school when you're learning trigonometry, they say there's no sinning in math class. That is true, but there is signing. And S-I-N-I-N-G is a unique linguistic iteration of letters. S-I-N-I-N-G is not defined. But it's sensorality. You had like 1 second to contribute to math. But this is a recorded video, so you didn't. And you lost, because I already did it on my phone, like 2 hours ago. And so we're getting really, really close to the reduced definition, but that is the axiomatized fundamental ing, like it's the fundamental stability of 2 with a fundamental syllable of ing, singing. But now we're signing. And so we just drop that G and we drop that N from sinning. And there's literally that phrase that, there's no sinning in math class, but there's signing, and we have our sine function. So we've literally derived the linguistical form of sine function. So now we're into trigonometry. So we can literally derive all of mathematics from the simple empirical fact that everything is connected, but nothing is touching. Nice. But you have to have a math subject in your head. I would say lucky for me, but my life fucking sucks. But that is a fundamental proof of our unique linguistic order of letters. Signing. Sensorality is signing. So I'll do some more derivation and I'll see you on the next one.